Okay, so how can I find the max and the min for a quadratic function from standard form? Obviously, if it was in vertex form, that would be really easy. Now keep in mind that maximum and minimum values, these are y values of the vertex. So if you can find the y value of the vertex from a picture or from vertex form, man, that's a piece of cake. But if you're given standard form, then you got to think about it. You got to do a little work. In the formula here, so right below this is an example. If an object is thrown upward, its approximate height, okay, that's like your y value, in feet is given by this formula. Okay, let me uncover that a little bit. So height, that's like your y value. T, you see the t value twice, that's like your x value. Okay, now you're like, what are these other letters? The v and the c. Okay, so in the formula, t is the x and it's time, right? Time in seconds, usually seconds. If you're launching an object, it's not going to come down. Oh yeah, that says it in seconds. V is the initial upward velocity. Initial upward velocity. All right. C is the initial height. That's how high off the ground the object was when it was launched. Okay. So let's get an example here. Toy rocket is launched upward with initial velocity of 40 feet per second. Well, that's the V part. The toy rocket is on a table that's 3 feet high. That's the C part right there. So, write an equation for the situation. H equals negative 16 t squared plus 40t plus 3. Now, generally speaking, it's going to go, maybe it'll do more like this. It's going to go up in the air and come back down. Now, remember, this is not the flight path of the object. Not the flight path of the object. It did start from a height of 3 feet off the ground. I mean, this thing could have gone straight up and straight back down, to be honest. What is the height of the rocket after 1 second? Okay, well, so they're asking me to plug in a 1. We can do that pretty easily. Okay, so what do we got there? 1 squared is 1. 1 times negative 16 is negative 16. Okay, please understand I'm using the order of operations. I did this part first, then I multiplied it times negative 16. And then I have 40 times 1, which is just 40, and then I have a plus 3. So we end up with, what is it, 24 plus 3 is 27 feet. So, part B. In how many seconds will the rocket reach its maximum height? Okay, well, remember, that's about the vertex, right? And we know that to find the first part of the vertex, that would be the opposite of B over 2 times A, which is negative 16. So we have negative 40 over negative 32. What does that happen to be? Is that 1.25? I think it's 1.25. I'm going to look that up. Yep, 1 1/4. 1.25 seconds. 1.25 seconds. Now, what will the maximum height be, right? So we know that right here in the middle is 1.25 seconds. Now, don't make the conclusion that it hits the ground at 2.5 seconds because we didn't start on the ground. If the object started on the ground, then yes, I could just double that, right? But the distance here is 1.25, and the distance here is more than 1.25. Now I know, I'm getting ahead of myself. So this is asking for the maximum height of the rocket, which is the y value here. And so let's use our equation. H equals negative 16 times 1.25 squared plus 40 times 1.25 plus 3. Okay? So, using my handy dandy calculator, see if I can split my screen. So, negative 16, 1.25 squared plus 40 times 1.25 plus 3. Looks like 28. Maximum height is, I should say, max height equals 28 feet. Example 2, interpret the graph of a quadratic. The graph of the function shows the profit a company earns from selling headphones at different prices. So I'll probably talk about this more in class, but if you sell it for less, people think it's junk, and so they don't buy it. If you sell it for more, people think it's too expensive, and they also do not buy it. So there's a happy medium somewhere in here where the vertex is sitting, and that gives you the best selling price to make the most money. Okay, so we're going to come over here and we're going to find what's the maximum profit that the company can earn. So they actually want a y value, right? All right, so I can start with the x value, right? Opposite of b over 2 times a, right? So negative 700 over negative 20. Of course, 0, that cancels out, and then the negatives cancel out, and that leaves me with 35. So 35 is the correct selling price. Did they ask me that question? No. They wanted me to find out the maximum amount of money I can make. So, truthfully, they want me to plug in 35. Okay. Negative 10 times 35 squared plus 700 times 35 and a minus 6,000. So now we're going to split our screen and do that again. Well, let me just double check my numbers. Negative 10, 35 squared plus 735 times 35 minus 6,000. Looks like we got 6250 as our final answer. Oops. 6250 as the maximum profit to this question. That takes care of that one. Alright, so let's see what's happening here on example 3. Maybe I should just keep my screen split, make it go faster. Small independent movie company determines the profit for producing N DVD copies of a recent release is this formula. P is the profit in $1,000. N is the number is in thousands of units. How many DVDs should the company produce to maximize the profit? Ooh, and what will the maximum profit be? In other words, they want both parts of the vertex. Okay. So we know that N will be the opposite of B over 2 times, and that is 2 times negative 0.02. Okay, so negative 3.4 over negative 0.04. Come over to my handy dandy Desmos machine here. Negative 3.4, and because I'm doing a negative over a negative, I know it's going to be a positive. Looks like 85. Now remember, that's in thousands. So I guess, right, because it says 85, I'm going to put 85,000 DVDs. Okay. Now, what do I plug in? I plug in 85. Don't plug in 85,000. Okay, I'm just interpreting what I have. So negative 0.02 times 85 squared plus 3.4 times 85. Running out of room, minus 16. Okay, so come back over to my calculator. Negative 0.02, make sure that says negative 102, parenthesis, 85 squared plus 3.4 times 85 and a minus 16, so 128.5. Now what does that mean? P equals 128.5. That says, let's see up here, what does it say? P, the profit in, oh, now did I make a mistake? Yeah, I made a mistake. It's not 85,000. It's actually producing 85 DVD copies. Oh, the P is in thousands. Oh, no. I was right. N is in thousands of units also. Okay, I'm not losing my mind. But 128.5, that's thousands. So that's really $128,500. Okay, so not making tons of movies, but or money. It is a small independent movie company, but that seems like a lot of DVDs for a small amount of profit. I mean, look, you're making like, I don't know, $1.50 a DVD. Doesn't seem like the most best profit. Okay, so Bree hit a golf ball from the ground. Ooh, right there. Told me that the C value was equal to 0. The initial height or initial velocity of the golf ball, right? That's your V. Write the equation for this. Okay, H equals negative 16t squared plus 80t. But I'm not going to put plus 0 at the end. That would be a waste of time. How long will it take for the golf ball to reach its maximum height? Okay, so that's the first part of the vertex. Opposite of B over 2 times A. Okay, so this is going to be the time, and we're going to come over here, and negative 80 over, parenthesis 2 times negative 16, 2.5 seconds. Now, this is one where I can double it, but we won't talk about that right now. 2.5 seconds to reach the maximum height. What is the maximum height? Okay, so now I'm going to plug that in, right? Negative 16 times 2.5 squared plus 80 times 2.5. And this graph is going to look like this. Now remember, 2.5 would be in the middle. Because it started out here at 0 and it's going to land at 0, that will be 5 seconds. Not that I don't know if they're going to ask me that, but we're going to figure out what the max height is here in a second. Come back over here, delete all that. Negative 16, parenthesis, 2.5 squared plus 80 times 2.5. And it looks like we got 100. Maximum height was 100. Okay. What's a reasonable domain? Now, a reasonable domain would mean how many seconds, right? This is domain would be your x's, which is your time. According to my picture, it would go from 0 to 5 seconds. What's a reasonable range? Okay, range goes with the y values, right? My y values here are height. So, what's a good low value? 0. What's a good high value? 100. All right? So, that's reasonable domain and reasonable range. What is the height of the ball after 1.5 seconds? All right, so h equals negative 16 times 1.5 squared. plus 80 times 1.5. Alright, so I'm going to just come over here to my Desmos, change that to a 1, change that to a 1. Got 84. And the question, the better question is this: will the ball reach this height at another time? Well, okay, so basically, if I come back up to my graph and I draw the line for 84 feet, will it cross once on the way up and once on the way down? And the answer is yes. Okay, so if this is 1.5 seconds, then could we use that to come back 1.5 seconds? And if we do that, what is 5 take away 1.5? Isn't that 3.5 seconds? So I'm going to try this. I'm going to come over to my Desmos and just try and see if 3.5 works. Oh my goodness, it did work. Okay, so at 3.5 seconds, we will also be at 84 feet. So 84 feet was the answer for the first part, and 3.5 seconds, because we're just using the idea of 1.5 seconds being the distance from the left and 1.5 seconds being the distance from the right. So that means this is 3.5 seconds to also reach a height of 84 feet. And I think that's all this example asks. Let me check. Yep, I was right. See you later.